This project is exploratory analysis of rainfall data in India. We study rainfall patterns using data analysis. The goal is to understand trends and climate changes. Now we will see introduction. Rainfall is very important for agriculture and daily life in India. We analyze rainfall data to find patterns and seasonal changes. This helps in better planning and prediction. We will see overview and purpose. This project aims to understand rainfall trends across India. We compare regions and identify flood and drought patterns. It supports better decision making. We will see ideation phase. In this phase, we identify the problem of uneven rainfall. Some areas get floods and some face droughts. So, we decided to analyze rainfall data using EDA. Next thing is requirement analysis. We collect rainfall dataset and analysis tools. We use Python, Excel, and visualization libraries. These are required to perform data analysis. Project planning. We plan the project in steps like data collection and analysis. Each stage was scheduled week by week. Next, project design. This slide shows the design of our analysis system. It includes data input, processing, and visualization. We perform data cleaning and exploratory analysis. We use graph and charts to understand rainfall patterns. This makes the data easy to interpret. We test the system for accuracy and performance. Lastly, results and conclusion. This slide shows the final analysis of results. We observe rainfall trends and seasonal variations. This chart shows the most of the annual rainfall comes during the monsoon season, contributing nearly 75%. Pre-monsoon and post-monsoon seasons add around 11 to 10% each, while winter contributes very little. Overall, rainfall is mainly dependent on the monsoon. The slide shows the seasonal rainfall trend variations across India. The maps indicates that rainfall patterns differ significantly by season, with noticeable regional increases and decreases. Overall, the trends are not uniform and vary across different parts of the country. This slide presents Indian subdivisions and long-term rainfall trends. The graph shows fluctuations in annual seasonal rainfall over time, highlighting variability rather than a consistent increasing or decreasing trend. Let's see literature review. This project is based on studies from the Indian Department and Climate reports by IPCC. Now, data description. I used the IMD rainfall dataset from 1901 to 2020, which includes yearly, monthly, seasonal, and state-wise rainfall data. Tools and technologies used. Python was used for analysis with Pandas and NumPy for data handling and Matplotlib and Seaborn for visualization. And now we will see about data pre-processing. I clean the dataset by handling missing values, removing duplicates, converting data types, and aggregating monthly data into yearly insights. Objectives of the project. The goal is to analyze rainfall trends, identify seasonal patterns, detect extreme events, and understand regional variations. Perform descriptive statistics yearly and seasonal analysis, state-wise comparison, and correlative analysis to uncover patterns. It is the exploratory data analysis. We will see about data visualization. Different charts like line graphs, bar charts, box plots, heat maps, and histograms were used to clearly present rainfall patterns. We will see about findings and insights. The analysis shows highest rainfall in Kerala and northeast states, lowest in Rajasthan, and strong dependence on the southwest monsoon. Finally, the conclusion was rainfall in India shows strong seasonal and regional variations, highlighting the importance of continuous monitoring. And the future scope is in the future, machine learning models and satellite data can improve rainfall prediction and climate impact analysis. Now I'm starting the code execution part of our project, which is exploratory data analysis of rainfall data in India. Here we can see the main steps of our project, which is exploratory data analysis process. First, we import the required libraries. Next, we load the rainfall dataset. Then we clean the data by handling missing values and errors. Finally, we analyze the rainfall patterns to understand trends and variations. Slide shows the libraries used in our project. We import Pandas for handling and analyzing the rainfall data and Matplotlib for visualizing the data in graph format. These two libraries help us perform data analysis and create clear visual representations. Slide shows how we create a sample dataset for our project. We define the data with two columns, year and annual rainfall in millimeters. The dataset contains rainfall values from 2018 to 2022. Finally, we convert this data into a pandas data frame so that it can be easily analyzed and visualized. This slide shows the summary statistics of our rainfall dataset. Using the describe function in pandas, we calculate important values like count, mean, standard deviation, minimum, maximum. These statistics help us understand the overall distribution and variation of the rainfall data. This slide shows the visualization of our rainfall data using a line graph. The x-axis represents the years and the y-axis represents annual rainfall in millimeters. The graph clearly shows how rainfall increases and decreases over time, helping us understanding the overall trend in a simple and visual way. We saw some steps of the idea. Then here I am importing all the required libraries such as pandas, numpy, seaborn for data handling and visualization. I am also importing machine learning models from sklearn, XGBoost for model building and evaluation. I am loading the dataset using pandas read CSV function. I am checking for missing values in the dataset using the isNull function. This helps us understand which columns contain null values so we can handle them properly during the data cleaning process. Here I am initializing different machine learning models like XGBoost, Random Forest, SVM. Then I train the models using the training data, making predictions, and finally compare the accuracy scores to find the best performing model. After loading the dataset, I am displaying the first 5 rows using the head function. This helps us understand the structure of the data, including the columns and sample values before starting further analysis. Here I am using the describe function to get the descriptive statistics of the dataset. It shows the count, mean, standard deviation, minimum and maximum values, which helps us understand the overall distribution of the data. Dataset download and loading. The rainfall dataset is downloaded from Kaggle using the Kaggle API. Then the dataset contains rainfall data for various Indian states such as Bombay, Bangalore, Nagpur, Tamil Nadu, Kerala, Goa, Haryana, Delhi, Rajasthan, and etc. And rainfall data from year 2004 to 5 up to 2021 to 2022. Now we can see the graphical analysis is performed to study rainfall trends like heat maps and line graphs to understand the variations. In the final step, the system displays the prediction results for today's weather. If the model detects a high probability of rainfall, it shows chances of rain today. If no, the probability is low, it displays no. This is our agri rainfall prediction system called Krishi Varsha. In this module, farmers enter important weather details like temperature, humidity, wind speed, pressure, and rainfall data in the input form. Based on these parameters, the system analyzes the data and predicts the probability of rainfall. If there is a high chance of rain, the system suggests farmer to pass irrigation and fertilizer usage to avoid loss. Finally, all project files and reports are organized and sorted properly for documentation and future. Here, the model predicts the chances of rain for today. If the output shows rain, it indicates a high probability of rainfall. If it shows no rain, it means the weather is likely clear and suitable for outdoor activities. Conclusion: our exploratory data analysis of rainfall data in India helped us understand rainfall patterns, trends, and variations over time. By using statistical measures and visualizations, we gain meaningful insights that can support better planning and future climate relation decisions.